Hello and greetings and a very, very warm welcome to all the attendees, participants who have logged in today and who are always following up as well. Many, many familiar faces who have attended the earlier sessions. So very warm welcome. To begin with, I would like you to familiarize yourself with the controls. While I'm sure you would have attended many such webinars on Zoom. At the bottom of your screens, you have a button which opens up a chat window. You also have a button that will open up a question and answer window. We would encourage you to write the questions that you would like to ask in the question and answer window and not in the chat window. And the main reason being this, that the questions written in the Q&A block gets saved as well. So in case we are unable to answer any of the questions, these questions can be replied back at a later date, and I can come back to you through an email or a phone call. This webinar and all the interactions are recorded, as you would be familiar. I would be sharing the recording later. Hopefully by Sunday, the recording will be online on our YouTube page. You can access our YouTube page to look forward and look at all the old and the past webinars that have been recorded. Like most of the webinars we have been doing, you will have a poll question. Whenever you see this icon blinking on your screen, please be ready to answer the questions that come across. They really help us in the future. My name is Abhishek Chabra. Many of you are probably familiar with me and we've known each other. I am a big enthusiast related to conformity. I've done lots of things in the last 15, 20 years, a lot of it linked to conformity and compliance. I have a blog/website and a LinkedIn group called Gurus of TIC. And I'm an active member in many avenues related to conformity and compliance. I represent as compliance and conformity related to it. Today, we take a deep dive into understanding fire resistance tests. And as always, we are catering to a very broad spectrum of people, attendees. Many of you are architects, are not necessarily engineers across various fields and functions. So we try to keep the flow of knowledge as simple as possible. So beginning with today's topic, I'll start with an interesting GIF I found in SimCity. A lot of us, whenever we talk about fire safety, we talk about that we want to prevent a big accident. What is this big accident? It is not something like this that you see on the screen. What we are trying to prevent is that we know that there will be fire incidents or small accidents, if I call it, in various places, in our houses, in our offices. But what we want to do, we want to ensure that a small accident should not become a big fire incident, a big tragedy. And the aim is to always minimize the potential damage and make sure we are able to control it. So today, as we better understand fire resistance and we take a deep dive to look at how to make sure that a small incident does not become a huge big accident. And we look at this across many aspects of the role of the construction industry, which starts primarily at the design phase when we are designing either a township, a city, a building, any kind of infrastructure. We need to understand why, how, what is fire resistance? Why does it really come into play? And this understanding continues not just from it continues from the design phase into the construction phase. When the construction is being done, a good understanding of fire resistance is critical. And it, of course, does not stop at construction. When we are furnishing, when we are planning the fit outs, as well as handing over the occupancy to the final occupant who will be living, running a facility, and using the infrastructure, as well as maintaining it, doing changes, breaking walls and making them again, adding utilities. Throughout the course of imagination of a piece of infrastructure till the tenants are using it, a good understanding and a proper comprehension of fire resistance tests is very, very important. And it goes a very, very long way. So what is this fire resistance? And let me begin with a very basic understanding of fire protection. We all know that a fire can get initiated anywhere, whether you are in a house, in a commercial building, in a manufacturing location, in an airport, anywhere. So through the decades, through the learning, there are two concepts which have come to be to ensure that in case there is a fire that breaks up, we make sure that it does not grow. And these two approaches are very simple approach. There is a proactive approach and there is a reactive approach, as we always have. The reactive approach is very visible to all of us. And what it does is that the moment there is a fire or a fire kind of incident, it is detected. This detection is in the form of smoke or fire alarm systems and smoke detectors. And there is an action that it drives. It could give out a siren, it could give out a song message to evacuate. So all of these equipments, manual, automatic, or systems which detect a fire after a fire happens and creates a process that will make sure that we minimize the damage. The building can be evacuated, the fire tenders can be called. This is all coming under an active fire protection. It is a reactive approach. The proactive approach is what is often called as a passive fire protection approach. What passive fire protection approach does is that we make sure that in case a fire does break out, it does not react with the material in the surrounding and grow very, very quickly. It also has a methodology to make sure that the fire gets compartmentalized, blocked, or contained in the area where the fire has initiated, often called as resistance to fire, compartmentalization, etc. And we will talk about this throughout the course of today's session. Often words like containment are used. And what does this really mean? It means that the fire is contained in a room, in a floor, or in a section of the floor so that there is enough time available to evacuate the rest of the building and so on and so forth. Ignition and spread of fire is also part of passive fire protection, but this is not something that we will discuss in detail today. It is a subject of a future webinar. And another aspect which I will touch very briefly today is also called as structural fire resistance. And this is something that became a very talked about subject after the 9/11 tragedy, where one of the theories was that because the temperature of the fire had become so, because of the fire and the temperature in the building collapsed. So after such an incident, structural fire protection, or the fact that structural elements like beams, columns, steel, etc., can lose their structural strength when they are exposed to very high temperatures for long durations. It is prevented that this situation is prevented that there is a structural collapse. And hence fire resistance as a concept is also used to explain and take care of resistance to fire of the structural elements. Let's look at how this gets done and how this gets delivered. We talk about compartmentalization, as I explained earlier. And what this means is that the fire has to be contained for a given duration of time. And what is this time? How does this come about? Often you may have heard of someone saying that this wall is fire rated for 2 hours or 3 hours. What is this concept of time? And who really decides this time is something that I often get asked. We are looking at the concept of containment, time for which the fire gets contained in a given room, floor, or section of the room is enough time for you to evacuate the whole building or the whole area, enough time for the fire tenders to come in and take care of controlling the fire. And various jurisdictions, municipalities, as well as even tendencies of people in a given region affect the evolution of what is the right number. Large occupancies like malls or hotels or hospitals, they all affect in terms of how many people are there and how quickly they can be evacuated and so on and so forth. As you can see from this image, that there is a fully grown fire in one part of the building, and the floor above, the floor adjacent look almost unharmed. We need to evaluate and make sure that we are able to contain and create this environment. How do we test this? We test this by recreating an environment just like this. What you see on your screen is how the furnace where the test is conducted to evaluate looks like. As you can see, probably it is this furnace, which is our furnace, is a 3 meter by 3 meter furnace. It has 12 burners on the sides, and it has several mechanisms that can help us recreate a fire scenario of a fully developed fire in a room, a fire gone out of control. And it helps us simulate an environment of high pressure, negative or positive, depending on the type of tests that we are doing, as well as these help us create what we call as time temperature curves. What does this mean? We recreate the system or the product that needs to ensure and comply that this element, like these two doors that you can see in the video, that these elements are able to resist or contain a fire just like that in a real scenario for a specific duration of time. These fire resistance tests can often run for up to 3 hours or even 4 hours, depending on what we are testing, as well as depending on the regulation that exists in that geography where that is being demanded. As you can see, there is a graph running on the left when the pointer is showing that how, with respect to time, the temperature inside the furnace has been increasing. And you will notice that very, very quickly, within 5 to 10 minutes of starting the fire resistance test, a temperature peaks. This is what is called as the standard fire curve, ISO curve, and it has many, many names. And this is exactly where the questions get popped up, and people want to try and compare, saying, wait a minute, what exactly are you trying to replicate? What is the scene? So what this tries to replicate is, as I said, a fully grown fire, and it measures several aspects of pressure, as well as how the fire resisting element, whether it is a wall, a door, a glazing partition, or a structural steel element, is able to contain or resist fire. You would notice that there are generally two types of fire curves, as you can see on the screen. There is the American approach, the ASTM E119 or UL263. There are several American standards which follow the same time temperature curve, which means they follow the same rate of increase of temperature with a minor deviation, as you can see. And to try and address a very, very complicated question that comes to us, because we are in a part of the world where we test as per several standards, whether they're American, they're British, they're European, the ISO, that why are there so many standards? And it is almost like all of us who are familiar with COVID, and there is a constant debate nowadays that the vaccines are out. So many companies, countries, people, perspective, they have created vaccines. Which one is more effective? What does one do, etc., etc. So let's just rewind back to a few hundred years when humanity was faced with fires, and we were trying to emulate and create almost a standard protocol that would show how a fire can be recreated in a laboratory scenario. So almost two groups, the American standard and what was in the UK, I think the British standard, the BS476, as well as the European standard. And when the world kind of came together in International Standardization Organization, or ISO, was formed, is a time temperature curve evolved. The concept becomes a little more complicated as more and more types of products need to be evaluated for their fire resistance behavior. Some of the images that you see on your screen, you see a dampness, and another image on the right, which doesn't quite look very clear, is basically through penetrations, which means all the utilities, electrical ducting, which is created usually above the false ceiling that you don't see. How all of these can be tested almost in the same manner like a door or a partition is tested. And hence, what you get is a huge array of different test methods, different product groups. And what you see on your screen is almost like a snapshot of some of these categories of tests, and the standards that you see on your screen, and they seem to be swaying up and down, which is kind of deliberately done so that all the listeners are nodding to what I'm saying. But no, it's on the screen basically to help you read through while I talk, because a lot of times people want to understand, hey, what is the standard for a ventilation duct? What is the standard for a partition? Is there an equivalent in the American standards? What is the equivalent in Europe? What is the equivalent in India? What standard should I use? And we have been very lucky in the UAE since we became and we started testing for a lot of people around the world, because the UAE Fire and Life Safety Code has had a very different approach. It has had open doors. It does not limit to specific standards, which are either European or American or British or ISO. It allows several standards to be used. So we were lucky, and we were exposed to several different test methods. And we have seen many of these tests, almost the same product being tested to the American version, to the British version, to the ISO version. And now lately, as we have also added the Indian standards. So such a comparison, of course, is done by us. And again, we are faced with the so-called difficult question that how do you really compare all of these standards from different parts of the world? And then almost perennial, always we get a question, um, which standard should I test to? Should I test to American standard? Should I test to British standard? Should I test to ISO standard? And the question and the intensity of question varies, of course, because if it is a manufacturer, their approach is different. If it is a regulator, if it's a consultant, their approach is different. So I would like to set an answer straight for everybody to know and understand that how these standards should be compared, whether they can be compared or not. The first criteria is market entry. There are regions, geographies, countries, jurisdictions, sometimes even projects who would set out a minimum requirement as per a defined standard. You could have a project in India or UAE or Egypt or Saudi Arabia or Kuwait or Bahrain, or even in Europe sometimes, who may call for compliance to an American standard. But mind you, the minimum legal requirements set in by a country set what we call as market entry requirements. Often, countries and jurisdictions prefer to have their own standards developed by their region and their country to be adopted as the minimum norms set in by the government to allow products to come into the country or get sold in the country. And this sets the requirement. What test method should you test to is often driven by market entry requirements. What are the norms in a given country? The second comes from safety. And what is safety? How do you drive safety? Well, it starts with either the building code, which sets the minimum norms and which sets a synchronism among the standards of different products, as well as among the approach that has to be followed to ensure that there will be safety. Whether you have to stay indoors when there is a fire and do not evacuate, even if the fire is in your building because it gets contained somewhere else, is a concept that has been created in a specific place, or you are all supposed to run and evacuate out. These define the flow, the methodology, and many a times certain types of occupancies like hospitals, airports, malls, or certain commercial buildings will have their own regime of what to do in case of a fire. And this regime is driven by the philosophy of fire and life safety design. There is a plan that has been done that in case of a fire, how the property or the type of occupancy has to be protected. So it is very important to look at what is the type of occupancy, what is the theme, the concept, and the vision. And hence that will drive down to say what standards should we test to validate the fire resistance. And the problem comes in many areas where choice exists. You can choose any standard, and this choice should be used properly. If you are designing a building, let's say a hotel, with the philosophy of how an American code works, or a British code works, or a European code works, then whatever standards for tests, for installation related inspections are done, they should all be synchronized. You cannot really come up with a concept of egress or evacuation as per the European code and have a fire door or a partition tested to the American standard with components which comply to British standards. It can be done, and I'm not saying it does not work, but it is something that will always and always require a microscopic view, someone who really understands the interplay between these standards. And the reason why I say this is because the concepts are different. And I'll take an example from something that I had been done recently. We have been since we added our horizontal furnace, we've had a lot of requirements of people saying we want to test HVAC ducts. We want to test ducts as per the British standard, as per the EN standard. So I started to do a lot of work saying, wait a minute, what all standards we should be adding. And I scanned quite a few of the codes which are applicable in the regions that we support. And I realized that while the British standard exists and the European standards are there, I found it very difficult to find an American test method for testing fire resistance of the ducts. I mean, I found an ASTM standard or maybe one or two others, but when I scanned the Saudi building code and even the American IBC codes, I realized that the approach to validate and ensure that the fire does not spread through the duct is different in the American code. It is not like that of the European norms. And hence, uh, I don't think, if somebody could correct me if I'm wrong, but if you find a fire resistance standard in the Saudi building code or the IBC, please, I would love to hear what is these standards. And hence, the real trouble usually is in when people are designing a building with mixed codes, with mixed requirements. And there needs to be a harmony between the requirements that are behind the design ideology, behind the philosophy of fire and life safety. What is the flow and the concept that you will make sure that the fire does not cause harm, building can be evacuated, fire can be contained for a given duration, what is that duration, and so on and so forth. So let me move to the next phase, and I'm going to open a poll question, my favorite. There are a few questions today, so I'll give you a few seconds to please answer the questions in the poll so that I can move to the next phase of our session and I can take a small water break. People who've been attending our webinars would realize that this is quite a favorite question of us, that what is your primary role? And it really helps us understand the perspective that you would be coming from when you are trying to understand passive fire protection or implementation of passive fire protection, because everybody's perspective is different. A manufacturer's perspective is probably, as I said, market entry, whereas someone who is an architect, someone who is the government body or the authority having jurisdiction, their perspective is different, their focus is different. And throughout the flow of various stakeholders, like as an example, what you see on your screen, these hexagons in blue are the people who are involved much more at the design phase. And then you have got a situation where other stakeholders, like the construction companies or the contractors, who are very much focused at a period of time when the construction is happening. Their motivations are very different, as you would understand. They have a specification document, they have something to comply to, they have limited time, they have limited money, they need to very quickly deliver it all. And then, of course, after the building is handed over, the building needs to be maintained. The occupiers, the FM companies who come in, they need to make sure that whatever the design was, whatever the initial concept was, that how and why the fire and life safety plan has been put in place, it needs to sustain itself. And this is where understanding of fire resistance helps. I'm now going to move forward and walk all of you through a fire test report. Anybody who has not really answered the poll question, I would urge you to answer the question while I tell you that what is it that you should see starting from what is tested, What are the test standards that have been used? As an example, the BS 476 has been published originally in 1987, and I think not revised a lot till then. Of course, I'm sure somebody is going to correct me in the chat later. You also look at the laboratory's accreditation. Who checks the checker? If there is a laboratory who is testing and checking a product, who is auditing them to make sure that they are doing their job right. And there is a slew of information. And let me walk you all through some of the very, very important aspects of it, starting with who is the sponsor of the test, who paid for the test to be conducted, when was the test done, what was the date, were there many people who were witnessing the tests, who were these people, what is the sample that is tested, what is its dimension. In fire resistance test, of course, the supporting construction is important. And you should know what the supporting construction is. What is the specimen? How is the specimen coming into the lab? Is the laboratory involved in selecting the sample from the factory? Who is involved? In certain cases, the certification body, who is going to later on use the test data to give assurance of supply of the product. They want to ensure that the product has been manufactured in a given way. The environment in which the test is conducted, which is the conditioning, is very, very important. What is the condition in which the test sample has been installed? This becomes important, of course, in cases of fire doors and many such products where mechanical properties are very important. Which side the door is opening, latched, not latched, several things that come into play. The test observations, of course, are almost like a summary of what is happening. You could see the video of the test as well as in parallel see, hey, what is recorded. It's almost like a flow of how the test happened, almost like listening to the commentary of a football match, saying what had happened. Integrity and insulation concepts known to many people is that for how long the fire was able to be contained, it was able to maintain integrity. And there are certain types of requirements related to insulation, saying whether the heat is getting transferred. So paths which are egress routes need to have much higher insulation, and it cannot have someone touching the door or the wall when you're running out and hence getting hurt. The fire resistance test also captures a huge amount of construction and design details. And these details are extremely important from many, many perspectives. One is, of course, for someone who is using the test report to match and see what is being installed at the construction site, at the supply site, what is it that is there, but also ensuring that a lot of components, materials, where are they coming from, what is their source, what is their dimension, density. All of these details are extremely, extremely important, because if the components are changing, if the design is changing from what was brought together and tested, then obviously the result will be very, very different. So a test report captures this huge amount of data, and of course, the way it was installed, where all the thermocouples were placed, which all areas where temperature was sensed when the emulation was done. Details which are important for inspection bodies and inspectors who will at a later date use this test report, or data from this test report will be used in conjunction with past data and experience to almost draw conclusions, saying, well, if something else which is similar and deviant from what is tested in some small ways is subject to a similar test, what will the result be? So you will also see that the thermocouples where the temperatures across the surface of the material are sensed. There are detailed graphs which capture the temperature throughout the course of the test that was done. So at the end of it, these test results are not just a pass or a fail, but a fire resistance test, hence captures a huge amount of information of where the door came from, how it was installed, what were the components of a door, how, and which help maybe certification bodies to use that data to say every time such and such door manufacturer sends a door of this design, the design which is in the test report or in the certification report, will comply and will always be able to contain a fire for 2 hours or 1 hour or 90 minutes and so on and so forth. So now that we understand what a test report is, hopefully you have a slightly better understanding. It is important to know, sometimes people miss this, that a test report is only proof that there exists the capability in the producer to produce a door which will, or anything, not just a door, a partition, or any element that we are testing for fire resistance. The manufacturer has the capability to produce something that can resist a fire for a given duration. And the installer who installed the sample in the laboratory has the capability to install the system which will contain a fire. And this is extremely critical because unlike measuring a commodity like maybe grains in a weighing scale or the flow rate through a pipe or even an electric cable, where what is being validated does not know it is being validated, versus when we are testing for fire resistance, the producer of the sample is aware that this sample is going to go to the lab and get tested. The installer of the product to be tested is aware that this system will face a fire resistance test. And this is a key difference which should be understood whenever we are seeing a fire resistance test report. Because yes, we understand what fire resistance as a property is, but we should also understand how this comes about. A fire door or a partition system is brought together using components and materials which are produced in manufacturing locations. And there needs to be a process in place that ensures that these are produced repeatedly. When there are through penetrations for utilities, which are cut and brought back together to a fire resistant system, there has to be some method to make sure that they will continue to be fire rated. And the same goes for the structural fire resistance that we are talking of, that not only it is important to understand that the chemical or the element that was used to create the property is able to maintain repeatability, but also repeatability is maintained while installation is being done. And this is something which is very, very important, close to my heart. After the fire resistance is designed, implemented, installed correctly, we have the services that have to come in. And these break open the compartments that have been so nicely designed, validated, and then installed and inspected at well are broken open. Sometimes while the construction is happening, and many a times after the handover of the building, the FM company is involved in saying, oh, I missed out a cable. The internet needs me to cut through the wall and make a hole. And how do you really fill that back in? If you fill that back in incorrectly, then the whole concept of designing a compartmentalization, making sure that if there is a fire, the fire will go out and will break through. So it is a whole different subject to talk about through penetrations, fire resistance in through penetrations. And few months ago, I had done a webinar dedicated to talking about this, and it is available as a recorded session on our YouTube page. But it is important to understand that when through penetrations or any compartment that has been designed and implemented to contain the fire is broken through. And there are known, proven methods, mechanisms, materials, and designs available to ensure that the compartmentalization is brought back to its original place. It requires a very, very careful scrutiny to ensure that, yes, these are being checked, these are being correctly installed, and so on and so forth. So how do we really use this knowledge that we have? We know that we are designing something that needs to ensure that fire resistance and the containment should function, because we really don't want a small accident to become a big incident, right? And we are also aware of the fact that there are errors that will happen while manufacturing is happening. These errors could be by choice or by chance, we don't know. We need good mechanisms in place, good checks and balances in place to make sure that the installations are done correctly. There are several aspects. So how do we really bring about this assurance? I'll give a small example of two of the very commonly used concepts or principles. In countries and jurisdictions where certification and listing as a concept is not very well used, you will have a contractor or a project management company review each and every component product. Let's say if you have 400 doors, which are of 56 types, then all of these are carefully reviewed and all of these have to be tested. Otherwise, how will you get an assurance? And the other method is where you get a certification and listing, not just a test report, which has all the data which needs to be verified respectively at every installation in the whole project. There are evolved and known concepts, which I talk about almost every time when I talk about, and I talk about like my favorite subject of certification and listing and how really, really important it is to bring about certain level of assurance. And this level of assurance is critical. It is much better than nothing at all. So you have a level of assurance where you have certification and listing, which is a big layer around and over just a test data or a test report, because there is someone who is not only witnessing how a sample was manufactured inside a facility. This body is constantly auditing the manufacturer, checking that they are able to maintain and ensure that same concepts are able to come across repeatably. And these concepts, what they result in is what is listed. A certain type of design, types of design, variations of what has been tested, which will all be able to demonstrate given properties of fire resistance, which are verifiable at the construction site. These details are available on the listing directory. And I welcome you to search not only our certification directory, which is tbwcert.com, but several certification bodies who make a lot of data public to ensure that they provide us the tools to ensure that when a certain product or a system is designed and procured, there is enough evidence available to inspect as well as to maintain that fire resistant assembly. With this, I hope all the listeners have a much better understanding of what fire resistance really is, how all it is conducted, how it can be used, and what are the real ways to ensure that we have fire safety in the given installation. I'm going to take a 10-second break now. I'm going to read through some of the questions that have been coming in, and I welcome all the participants to ask any questions that you think are important or related that I can answer in the next 5 to 10 minutes. Even if these questions are not directly related to the content that I presented, which was probably a bit generic because it is something where I feel it is important to evolve a basic understanding of what fire resistance really is, how it is tested, how it is validated. But please, I would welcome if there is any curveball, if there is any tricky questions you want to throw to me that I can take up in this public forum, which is getting recorded. And I'd love to answer some of these questions. So let me take a quick 5-second break. So I'm going to start taking some questions. There is what looks like a very detailed question. I'll see if I can answer this one while you can send me some other questions. Any insulation criteria in a staircase fire door? So very, very open-ended question. Again, comes back to understanding what is the occupancy type? What is the fire and life safety plan for that occupancy type that has come to be in relation to that jurisdiction? So you could have a jurisdiction like a country who has certain minimum requirements set in by using their code, the building code, that would set in the criteria or the requirement. You could have something that has been set in by the consultant or the owner. So for example, if there is an occupancy like a hotel, certain hotel chains, they have their own requirements set in place. So they would often go over and above the minimum requirements set in by the country. So yes, there are lots of criteria, and these criteria would vary depending on where the installation is being done. Another question, I like these questions. If nobody tested fire door without vision panel, but at site they applied, then what is the role of local fire bodies? Well, at the outset, any door design or door assembly that has been validated through tests as well as certification processes, it is only that combination of designs, components that will be able to demonstrate fire resistance. But if anything is changed, any component is changed, the assurance that is needed has to be redone. Whether you test again, whether you take an opinion of an expert who may be able to, by the virtue of their experience, say, yes, these changes are okay, these changes are acceptable, etc. But as someone who should be worried about a possible fire accident, as someone whose job it is to assure that nothing is going to happen, should really be worried about such changes and lack of evidence. Whether it is the local fire body, whether it is the building owner, whether it is the insurance company whose money is on the table, all of them need to be very, very sure that they look into these requirements and comparisons very, very carefully. Let me look at another question. I see that some questions are going in the chat. I would request you to please put these questions in the Q&A because the chat doesn't get saved. And while the chat is scrolling up, I might not be able to answer some of these questions. Let me look at another one. And I'll try to answer. I'm not like this. Why none of the manufacturers test fire doors for smoke rating in UAE? Whereas, as per UAE Fire and Life Safety Code, the exit should be fire and smoke rating. This is a great question. It's very difficult for me to say why someone is not doing something. It is probably, and I think you are from UAE, it is probably like asking me a question that why do people drive at 150 kilometers per hour on, let's say, Mohammed bin Zayed Road in places where the radars do not exist? But I really can't answer why someone is breaking the law when they cannot be caught. But yes, I hope that example kind of answers your question. Let me look at some others before the time goes up. How important it is to fill the fire doors in HMD? I'm not very sure, sir, what HMD is. This is debated much in India as the contractor doesn't think it is important. Without getting into what is HMD, I'm not sure. Whatever can get validated in the laboratory by certain tests is what is ensured or assured. If you are able to do a test and show that a given design which has filled or non-filled door frames, yes, it works. Whatever works, works. Whatever does not work, whatever is not validated in the eyes of someone outside, well, there is no proof, so I cannot really say it. And you have to rely on someone else who has almost like an experience to say, yes, I think this will also work. I hope that answers your question, sir, but please, if you can extrapolate, explain what HMD is, and maybe I can call you and try and answer this question. What is the difference between type of construction, type 2332 and type 2222? I am sorry, sir, I would not be able to answer this question. This is related to the code. I am not an expert of the code. I'm going to try and take one or two more questions. Hollow metal door. Okay, sir, hollow metal door, HMD. Fine. As I said, yeah. Let me take two more questions. Do you think the exit staircase fire rated door must be provided with intumescent seal in order to resist the migration of toxic smoke? So I'm sure there is a reason for sending this question anonymously. I cannot see your name, but I will maintain back the neutral concepts. There is no point in a laboratory or anybody saying that the only way to make a fire door or a fire and smoke door is using these components. It is like limiting any and every kind of flexibility of design and kind of stopping innovations. Anybody can come up with any concept tomorrow, whether it is using an intumescent seal or some other mechanism to ensure that smoke does not penetrate. So I would only say this as an answer to your question, that there needs to be a validation of the function that needs assurance. How it is validated is through a concept of tests, certification and listing, and inspection of installation, that the installation is done correctly. Whatever the design components could be, it could vary from place to place. Let me take one more question. Why external doors provided are fire rated doors for service rooms? Fire rating in case of partition doors is okay, but in case of external doors for the fire exit, which is opening directly outside the building, why fire rated doors are required? I am not very, very sure what is the ideology behind requirements like this. It could be because a containment needs to be created of a given flow or of a given building due to whatever reason. But this is something that we can discuss later on, and I can try and put my mind. So as we are a few minutes away, I'll take one more question. Oversized fire rated door assembly tested. So of course, there is a limitation to the size of doors that can be tested. We now have a 4 meter by 5 meter furnace, so we are able to test fairly large doors. But in terms of assurance and conformity of a larger door, shutter, or any kind of opening that is validated, a lot of it is based on scientific calculations, based on data experiments that have been done. So there is a lower degree of assurance when you rely on test plus the judgment of some experts, because often there do not exist concepts to check the parity of people's judgment, or what is the logic behind it. It's often very open to debate. And this is, of course, a very discussed, very debated point of view. I don't have a black and white answer to it, but yes, assurance, and there is always a limit to the assurance that you can get. So that is all for the day today. If there are some questions which I have left unanswered, and these questions are there in the question and answer section, I will be coming back to you and trying to, maybe I'll connect with some of you on a phone call or an email to talk about some of the questions, like the South African national standards. Somebody is asking questions about the South African national standards, that we are also accredited to the SANS standards. Well, we are accredited to these standards, and we can offer conformity. So thank you, all of you, to join in our webinar session. I hope it has been interesting, it has been informative, and of course, we would love to help you out in any of your compliance or conformity requirements. Stay tuned to our LinkedIn page and our emailers. We have a Arabic webinar series that has also begun. We do a monthly webinar in Arabic. Our CEO, Sandy Dweck, delivers those webinars every month. We are taking a closer look at the Saudi building code and working at increasing awareness related to compliance and conformity, again, as per requirements set in the Saudi building code. Very, very nice to connect. Do check our YouTube page. It has all the recorded webinars, and this webinar would also be going back on our YouTube page. Thank you very, very much for joining in. I will see you next month.